Thermodynamics is the study of the relations between heat, work, temperature, and energy. The laws of thermodynamics describe how the energy in a system changes and whether the system can perform useful work on its surroundings. In this section, we will deal with certain very important questions pertaining to thermodynamics. As such, what is the second law of thermodynamics? Explain enthalpy. What is the difference between the heat engine and a heat pump? Why is reversed Carnot cycle not possible practically? Explain the Otto cycle in brief, and many more. What is the second law of thermodynamics? The second law states that if the physical process is irreversible, the combined entropy of the system and the environment must increase. The final entropy must be greater than the initial entropy for an irreversible process. The second law of thermodynamics establishes the concept of entropy as a physical property of a thermodynamic system. The perfect answer to this question would be: the second law of thermodynamics depicts that the total entropy of an isolated system can never reduce over time. Name two vital conditions of a perfect gas. In physics, a perfect gas is a theoretical gas that differs from real gases. In perfect gas models, intermolecular forces are neglected. This means that one can neglect many complications that may arise from the van der Waals forces. The perfect answer to this question would be: a perfect gas should satisfy the state equation, and specific heat of a perfect gas always remains constant. Explain enthalpy. Enthalpy is a property of a thermodynamic system, which is defined as the sum of the system's internal energy and the product of its pressure and volume. It is a convenient state function standardly used in many measurements in chemical, biological, and physical systems at a constant pressure. The answer to this question is pretty short. It should be: it is the heat content of a thermodynamic system. What is the difference between heat capacity and specific heat of a material? Heat capacity is the ratio of the amount of heat energy transferred to an object to the resulting increase in its temperature. Specific heat capacity is a measure of the amount of heat necessary to raise the temperature of 1 gram of a pure substance by 1 degree Kelvin. The answer to this question would be: the heat capacity of a material is the amount of heat transformed to raise unit mass of a material 1 degree in temperature. What is the difference between the heat engine and heat pump? Heat engines produce work. Work is done on the surroundings. On the contrary, a heat pump requires work as input. Heat engine extract heat from a high temperature source, convert a part of it into work and reject the remaining to a low temperature sink. However, the opposite happens with a heat pump. When user supplies work to a pump, it extracts heat from the low temperature source and pump it to the high temperature source. Heat engine produces mechanical energy, whereas heat pump requires mechanical energy. In heat engines, not all the heat supplied gets converted into useful work. If all the heat supplied is converted into work, then it will definitely violate the second law of thermodynamics. Similarly, using a heat pump, you cannot pump heat from a cold body to a hot body without the input of external work. If no external work is done on the pump, and if the pump pumps heat from a cold body to a hot body on its own, then it will also violate the second law of thermodynamics. The sweet and short answer for this question would be: heat engine produces work and transfers energy from high temperature to low temperature. In a heat pump, external work is needed to transfer energy from low temperature to high temperature medium. Why is reversed Carnot cycle is not possible practically? Because adiabatic processes are not possible due to losses in the condenser pipes, compressors, and evaporator. Give the names of different thermodynamic processes. First would be isothermal process, which is a constant temperature process. Second is isochoric process, a constant volume process. Isobaric process is the constant pressure process. Throttling process or isenthalpic process is the constant enthalpy process. And last but not the least, we have isentropic or adiabatic process, which is a constant entropy process. Explain the Otto cycle in brief. An Otto cycle is an idealized thermodynamic cycle that describes the functioning of a typical spark ignition engine. It is the thermodynamic cycle which is most commonly found in automobile engines. The answer to this question would be: Otto cycle can be explained by a pressure-volume relationship diagram, as you can see here. It shows the functioning cycle of a typical spark ignition 4-stroke engine. The cycle starts with an intake stroke, closing the intake and moving to the compression stroke, which starts the combustion, followed by a power stroke. Then comes the heat exchange stroke, where heat is rejected, and finally the exhaust stroke. It was designed by Nicholas Otto, who was a German engineer.